Welcome back to AlgoJS. Today's question is leetcode 342, power of 4. So given an integer n, return true if it's a power of 4. Otherwise, return false. So an integer n is a power of 4 if there exists an integer such that n is equal to 4x. So the first example, n is equal to 16, which returns true. Why is that? Well, 4 to the power of 2 is equal to 16. Right? So there is a power of 4 that equals 16. 4 cannot be raised to any value that gives us 5. Well, anything to the power of 0 is equal to 1. So 4 to the power of 0 is equal to 1. So for this, we're going to be looking at two solutions. The first one is the recursive approach. So let's dive into that. So we have the value of 16, and we want to work out whether it's divisible by 4. So whether 4 can be raised to any power to give us 16. So one approach is to continuously divide this by 4 until we reach 1. So let's walk through that. If we divide 16 by 4, we get 4. And then if we divide 4 by 4, we get 1. So we know 16 can be recursively divided by 4 to give us 1, which means that's a power of 4. So there are some base cases we need to look at. So if n is less than or equal to 0, we can just return false, right? Because raising 4 to the power of anything cannot return us a negative value. Also, if n is not divisible by 4, so we're using a modulo here to get the remainder. And if this isn't equal to 0, so if it's not divisible by 4, again, we can return false from this. So what is the time complexity of this? Let's break it down. So 16 going to 4 is one step, 4 going to 1 is the second step. And we can use logarithm to express this. So log to base 4 of 16 is equal to 2. So base 4 is what we're dividing by. 16 is the starting value, and 2 is the number of steps that it takes for us to divide 16 by 4 before we reach 1. And because we're working with big O notation, which is in regards to scalability of an algorithm, constants can be dropped. And then this can be simplified to log n. So that's the first solution. Let's move on to the second one. So we briefly touched on the logarithmic equation. In this one, we're going to take a bit more of a deep dive. So log base 2 of n is equal to x. This can be converted to 2 to the power of x is equal to n. Log base 2 of n is essentially what power can 2 be raised to in order to give us n. Now, if n is a power of 4, then n can be expressed as 4y. And since 4 is the same as 2 to the power of 2, we can change this even further, where 2 to the power of x is equal to 2 to the power of 2y. So if we rewrite the logarithmic equation, we have log base 2 to 2y is equal to 2y. Now, anything multiplied by 2 is always even. So for example, 2 to the power of 2 is equal to 4. That's an even number. If we're looking at 16, 2 to the power of 4 is equal to 16. So we can assume that the power of 4 with a base 2 logarithm will always be an even number. And that is the logic we are going to use in order to solve it. The runtime for this will be O1 constant time because we're using simple arithmetic to solve it. Okay, let's code out the first solution. So this is the one with recursion. So we need base cases for this. So if n is equal to 1, we have found a power of 4. So we can return true. Now we need the base cases for when n is less than or equal to 0, because any power that is raised to a number never returns a negative value. So we can return false here. And then lastly, if n modulo 4 doesn't equal 0, so it doesn't return a whole number when divided by 4, we can return false. Then all it's left to do is carry out the recursive call, where we pass in n divided by 4. All this is going to do is recursively call is power of 4, updating the input until we hit one of these base cases, returning us the boolean of true or false. So let's give this a run, check to see whether it's passed. Okay, so that's the first solution. Now, for the second solution, remember for this one we said, as long as log 2 is even, then we can return true. So we need to return where n is greater than 0, and math log 2 passing in n modulo of 2 is equal to 0. And this right here is doing exactly what we've stated here, right? We're checking log 2 of n. We're checking if it's even, and if it is, we are going to return true. Let's give this a run. Submit it. And there you go. I hope you enjoyed the video. Don't forget to like, comment, subscribe, and as always, I'll catch you in the next one.